Welcome to the Physical Science 20 lesson for the RM11 assignment, mole-to-mole conversions. The balanced chemical equation presents the exact ratio of reactants consumed and products produced during the course of the reaction. Let's look at the following. This reaction tells us that when exactly 2 moles of carbon monoxide react with exactly 1 mole of oxygen, it produces exactly 2 moles of carbon dioxide. Also included in the equation is the delta H term, telling us that 566.0 kilojoules of energy have been released. Now that is not an exact number, and when we use it in calculations, this particular number would be limited to 4 significant figures. Since these are ratios that numerically relate every species in our chemical equation, they can be used in our dimensional analysis equation to convert from one chemical formula to another chemical formula. Also, since the equation included a heat term, it is possible for us to now convert from moles to kilojoules or from kilojoules to moles. Let's rip through a few practice examples before you take down the examples in your notes. How many moles of CO have been consumed? At 3.5 moles of O2 have also been consumed. So I write down my given 3.5 moles of O2, big brackets. I will want to get rid of moles of O2, so I will put it on the bottom so it can factor out. And I'm going to convert that to moles of CO. My balanced equation, it says that 1 O2 equals 2 COs. So top equals bottom. Moles O2 and moles O2 will factor out. I run it through my calculator, and that gives me 7 moles of CO. My given has 2 significant figures. My bracket is an exact ratio, so my answer must have 2 significant figures, so 7 becomes 7.0 moles of CO. How much heat is produced when 4.0 moles of CO2 have been produced? So again, I write down my given 4 moles of CO2, big brackets. I'll put moles CO2 on the bottom so they can factor out. And it says how much heat, so that means I'm looking for kilojoules. And I know I can go from kilojoules to moles or moles to kilojoules using this balanced equation. 2 moles of CO2 equal the production of 566.0 kilojoules of heat energy. Now, you're saying, but it's a negative, and you put it as a positive in your brackets. Now, when we're talking about change in enthalpy, that delta H, the negative tells us that it should be on the right-hand side of the equation. And that is as a positive number. If the delta H was written as positive, it would be on the left-hand side of the equation. So when we look at delta H, the positive or negative, remember that tells us which side of the equation we place heat. Mole CO2 and mole CO2 will factor out. I run it through my calculator, I get 1,132 kilojoules. To correct for significant figures, my given had 2, my bracket has 4. That means I'm only allowed to have 2 significant figures, so our final answer is 1,100 kilojoules. How much carbon monoxide must be consumed in order to release 250 kilojoules of energy? So I write down my given first, 250 kilojoules, big brackets. I'm going to put kilojoules in the bottom so they can factor out. We said if we do not start with moles, our first conversion is always going to moles. So I'm going to go to moles of CO. And according to my balanced equation, 566.0 kilojoules equals 2 moles of carbon monoxide. Kilojoules and kilojoules will factor out. I'll run it through my calculator. I get 0.88339 moles of carbon monoxide. Correcting for significant figures, my given has 2. My brackets have 4 significant figures, so my answer is only allowed to have 2 significant figures. So my final answer is 0.88 moles of carbon monoxide. All right, now take this down. Example 1. How many moles of water are produced when 4.0 moles of O2 have been consumed? We'll write down our given, 4.0 moles of O2. Big brackets. we know we want to get rid of moles of O2, so it will go on the bottom so it can factor out. And I want to convert moles of O2 to moles of water, so I will put moles of water on top. To make top equal to bottom, I look at my balanced equation, and it says that 2 water molecules equal 1 oxygen. Moles of O2 and moles of O2 will factor out. I run it through my calculator. 4 multiplied by 2 divided by 1 gives me 8 moles of H2O. I have 2 sig figs in my given. I have an exact ratio inside my brackets, so my answer has to have 2 significant figures. So 8 becomes 8.0 moles of H2O. Example 2. How many kilojoules of energy have been produced if 3.0 moles of water have also been produced? I start by writing down my given 3.0 moles of H2O. Put in large brackets, and moles H2O will go at the bottom so that they can factor out. I'm going to be converting to kilojoules, and to make top equal to bottom, I will use my balanced equation. In my balanced equation, it says the heat term is equal to negative 571.68 kilojoules, but I put it into the brackets as a positive. The reason why, well, if delta H was positive, the heat would be written as a positive term on the left-hand side of the equation because it would be a reactant. Since the delta H term is negative, it would be written as a positive 571.68 kilojoules on the right-hand side of the equation because it is exothermic and the heat is exiting. So the heat term always goes in the brackets as a positive term. And that is equal to, according to our balanced equation, 2 moles of H2O. Now moles H2O and moles H2O will factor out. I run it through my calculator. 3 multiplied by 571.68 divided by 2, and that gives me 857.52 kilojoules. My given had 2 significant figures. My bracket has 5. So that means, since it's all multiplication and division, my answer is only allowed to have 2 significant figures. So 857.52 kilojoules becomes 860 kilojoules. Example 3. How many moles of O2 must be consumed in order to produce 2.0 times 10 to the 4 kilojoules of energy? First, I write down my given. Big brackets. I put kilojoules in the denominator so they will be able to factor out. I'm going to convert to moles of O2. Looking at my balanced equation, 1 mole of O2 is equal to the production of 571.68 kilojoules. Again, delta H is negative in our balanced equation, but if it were written into the equation, it would be a positive on the right-hand side, and it goes into our brackets as a positive. Kilojoules and kilojoules will factor out. I run it through my calculator, and I get 34.98 moles of O2. Correcting for significant figures, my given has 2. The brackets have 5, so my answer is allowed to have 2 significant figures, so 34 rounds up to 35 moles of O2. Yeah, and that brings us to the end of the lesson. You're good to work on that RM11 assignment. Don't worry, this isn't a bad one. It's pretty short, not like the last one.